Hi there folks, and welcome to my tutorial on Intro to Arduino. The Arduino is a microcontroller platform. A microcontroller is like a miniature computer that is meant to talk to output and input devices. An example of an output device that you might want to control with an Arduino would be like a motor or an LED. An example of an input device, which is going to give data to the Arduino, would be something like a temperature sensor or a humidity sensor. Important to note about the Arduino is that the circumference is lined with these pins, which actually create the connection to the input and output devices that I was mentioning earlier. Another important note is that the Arduino has no operating system and only runs the code that you put on it. Go to arduino.cc, download the latest version of the Arduino editor, run it, go to the drop-down menus at the top, go to File, Examples, Basics, Blink. The Blink is a very standard testing sketch, so I'm going to go through it line by line just to give you guys an idea of what's going on. So a really important thing to note right off the bat is that the program is split into these two sections, this void setup, and then down here, this void loop. The void setup runs exactly one time right at the startup. It's kind of like the boot sequence of the Arduino. And then after it's run one time, the code in the void loop continues to run as fast as it can for the entire time that the Arduino is running. Okay, now let's start with this first line. Int LED equals 13. So here a variable is being declared. The variable is of the type int, which means it stores a value between negative 32,768 and positive 32,767. The name of the variable is LED, and it's being set equal to 13. Okay, so then we enter our setup. The only line of the setup is to run this function pin mode. The pin mode function sets a pin to be either an input or an output pin. It takes two arguments. In this case, the first argument is LED, which is a pointer back up to here where we set LED to 13, and then the second argument is output. So what this really is saying is set the pin mode of the pin 13 to output. Down here in the loop, our first command is this digital write. Digital write is an essential function because it changes the value of a pin. So here what we're saying is digital write to pin 13, and we're telling it to turn on. So it's providing the full amount of voltage it can, in this case 5 volts, which is enough to turn on the LED. Right after the LED is turned on, the next line of code that gets run is this delay. The delay is basically just telling it to wait before it goes on to move or run the next line of code. It's being delayed for 1,000 milliseconds or 1 second. After this 1,000 millisecond wait, the next command is this digital write, our pin 13 low. So it's turning the voltage off and then waiting for another 1,000 milliseconds before returning to the top of the loop and turning it back on. So from understanding this code, we know that when we upload it to the Arduino, the pin 13 is going to be alternating back and forth between high voltage and low voltage. High voltage, then low voltage. Unique to the Arduino Uno is that there's also an LED attached to the pin 13. So what's going to be happening is the LED is going to be powered when pin 13 is set to high, and then unpowered or off when pin 13 is set to low. So let's upload this and see what it looks like. Okay, so we can make this sketch a little bit easier to use by making our own variable. Let's call it int iDelay, and let's make it equal to 500. Now down here in our delays, we can replace this number with iDelay. And remember, we just said that iDelay is equal to 500. So imagine if you had 20 of these delays scattered throughout your program, And instead of changing them all manually, now you can just change I delay up at the top to whatever you want, and they're all going to get changed. So another way we can make this code easier to use is to write our own function. And in the process of making this function, we're also going to get some insight to how the built-in functions digital write and pin mode work. We can tell these are built-in functions of the Arduino environment because when we type them, they come out orange. If you look at these, there's the name of the function, and then inside the parentheses, there's some parameters that are operated on by the function. These parameters are called the arguments. Okay, so we're going to name our function after what we want it to do. So let's name it blink LED. We need to give it some arguments. The two arguments we need to give it is the number of the pin we're working on. So maybe int the pin, and then how long we want to be blinking it for. So maybe int the delay. Okay? Now, to actually blink an LED, what we need to do is, like we did before, digital write it high and low. So let's copy and paste in this code, but where this is hard-coded to just always operate on our pin 13 LED, we want to make this more general. So we're going to replace this with the pin, both instances of it. And instead of delaying for I delay, we're going to delay for the delay, which was just passed in. So now that we've done this, we can replace everything in our loop with this one line. We're going to call our function blink LED, and now we need to send it in the args, the pin and the delay. And so we can send it LED, which is equal to 13, and I delay, which right now is equal to 800. And this is really where we're going to see the strength of what we've done. So let's say we had another LED on pin 12. Here you can see I set LED 2 equal to 12, and then did pin mode to set pin 12 equal to output, so it's ready to send the high and low signals. So now we can call blink LED again and blink LED 2 by I delay. So now we can blink as many LEDs as we want without having to write this over and over again. Okay folks, in this final part of the Introduction to Arduino tutorial, I'm going to go through some basic breadboarding for you guys. I understand that it might be hard to see what's going on down here, so I'm going to try my best to give good verbal instructions, and there's also going to be some text instructions and maybe some infographics overlaid onto this. So breadboarding is a great way to really play with your components without soldering them together into something that's now unusable or has to be desoldered to be used. So I've got this Arduino Uno uploaded with just the very basic examples blink sketch, no modifications. So we should be getting our high and low coming off of our pin 13 here. So let's test this out. First thing we're going to do is hook from the power lines on this board over towards the power lines on this breadboard. Now if you look at this breadboard, it's got these lines on the side, which where anything that's plugged into any of these holes will propagate vertically along the entire stripe. Likewise, anything that's plugged into these rows will propagate horizontally. So I know you can't see this, but this fourth pin in this jumper is the voltage line. It actually says it right next to it in a very tiny text. And then the one right beneath it is a ground line. So I'm going to connect power to power and ground to ground. And you can see there's like a red line and a blue line on this. And I've got my warm color jumper hooked up to the red side and my cool color jumper hooked up to the blue side. And I can test that I did this right by plugging in my LED. This is a standard 5mm LED, and one contact is longer than the other. This is the contact that wants to be hooked up to the positive voltage. So let's try this out. Okay, the LED turns on. So it looks like the power to this board is good. So what we want is for our signal, our high to low, to be coming in to this, positive accepting receptacle, and then the other side is to ground. So I'm going to plug one side into the ground, and then the other side into, any of these rows over on this side. And then I'm going to go from the row that I plugged it into over to pin 13. Thanks for bearing with me through this somewhat basic tutorial. Please check out some of the links in the description and please stay tuned. I promise things are about to get a lot more interesting.